Hi, welcome to the Olympiad geometry. Let's continue our study on the correlation of triangle centers. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Here is a problem. Let OI be the circumcenter and incenter of triangle ABC. If CA, BC, AB form an arithmetic sequence, then OI is perpendicular to IA. So, if CA, BC, AB form an arithmetic sequence, then we know that CA plus AB equals to twice of BC, right? That means CA is the shortest edge. BC is a medium length of edge, and AB is the longest edge, which means these three laterals are not equal, right? So let's just draw it like this. Let me draw it like here. So okay. C should be here, right? A, B. And we want to find the circumcenter of this triangle. Then we find it from perpendicular bisector line here for the BC and for the AB. Right, this is point O. And we want to find the incenter. So that is point I. And then we want to prove that OI is perpendicular to AI. Right? So let's just extend this one to here and call this point as M. This is the midpoint, we call it N. And let's call the intersection point of the angle bisector of angle A and the perpendicular bisector of edge CB, OM and AI. So this point, let's call it K. We will use this point. Okay, so this problem is very simple on the problem set, but it's not a very simple problem. So the first thing is that we need to understand how we can use CA plus AB equals to twice of BC, right? And we know that AI is the angle bisector of angle CAB. That means, let's call this point as D, right? That means AC to AB equals to CD to DB. And we know that AC plus AB equals to twice of BC, and CD plus DB equals to BC. Right? See the relation here? That means CD equals to half of AC, and DB equals to half of AB. Right? Based on this ratio and this equation, we know this relation, and dB equals to half of AB. That means dB equals to Bn. Right? dB equals to Bn. And we already know that BI is the angle bisector of angle B. Right? So if we connect In here, we know that Bn equals to Bd, and Bi is the angle bisector of angle NBD. That means triangle NBI is congruent to triangle DBI. Right, that's what we can get so far. We don't know how to use it, but that's the thing we can get from based on this relation. And what else we can get here? Think about the OM. OM is a perpendicular bisector of edge BC. That means any point on the OM should have equal distance to point C and point B, which means for point K, we have CK equals to KB. Right, CK equals to KB. Okay, CK equals to KB. And we already know that angle CAK equals to angle BAK. Right? So if we assume, the circle radius of triangle CAK, okay, the radius of the circle of triangle CAK, let's set it to be R1, and let's set the triangle BAK, circle radius, to be R2. Right? We know CK equals to 2R1 times sine angle CAK. Right? It equals to CK equals to KB, right? KB. And KB also equals to 2R2 times sine angle BAK. And because angle BAK equals to angle CAK, right? Angle BAK equals to angle CAK. We know that R1 equals to R2. Which means triangle AKB and triangle ACK have same circumcircle radius, right? This is important. And let's just think about the figure like this, okay? What is AK? AK is an angle bisector of angle BAC, right? So if we just draw up AK here, let's see, this is an angle bisector, right? This angle equals to this angle, right? And also we have to maintain the form that CK equals to KB. So CK equals to KB, ACKB. Right, CK equals to KB. And we can also draw another kind of form. Right, we just find the perpendicular line here, find the, let's call this point as P. We find the symmetrical point from C to P, that's here. Let's call it X, right? This can also happen, right? That Kx equals to Kc equals to Kb, right? So look at the case that the triangle AKB and the triangle ACK. That's of case 1. And we have case 2 for triangle AKB and the triangle AXK, right? For both cases, they guarantee that this edge, the Kx or Kc equals to Kb, and they share an edge AK, and AK is an angle bisector of angle BAC, right? So let's think about these two cases. These two cases can exist for the conditions we get so far. However, for this condition that CA, BC, AB form an arithmetic sequence, this is, I call it axis, actually represent for C prime, right? You know, For this case, that CABCAB form an arithmetic sequence, then AC prime B is no longer valid, right? Because AC prime equals to AB, which cannot form an arithmetic sequence to AC prime, C prime B, and AB, right? So that means this is the only case can exist under the condition that CABCAB form an arithmetic sequence, right? That means, okay, based on that, then we know for the triangle ABK and triangle ACK, they sharing the same edge AK. That means the circumcenter of triangle ABK is on the perpendicular bisector of edge AK, right? So you can imagine that from AK, from the perpendicular bisector of edge AK, there is a point, and this point has a distance with point A, point K, point B to be R2, right? And it also has a same, because the radius is the same, right? So that point has the same distance to point C, which means the circumcenter of triangle AKB, which is on the line of perpendicular bisector of AB and also on the line of perpendicular bisector of AC. That is saying that the circumcenter of triangle ABK and triangle ACK is same to the circumcenter of triangle ACB, which is point O here. And it is saying that ACKB are cyclic, right? So we get ACKB are cyclic. This is only valid if ACKB is like this shape, not like AC prime KB, right? We just proved that. Okay, we got ACKB are cyclic. That's very important. Then we know that angle ABK equals to angle ABC plus angle CBK, right? And what is angle CBK? Because KB equals to KC, so angle CBK equals to angle KCB. And angle KCB equals to angle KAB, right? Because ACKB are cyclic. So that equals to angle ABC plus angle BAK equals to angle BAC plus half of angle ABC plus half of angle BAC, right? That's an angle ABK. And let's look at angle ANI. See, angle ANI is 180 degree minus angle INB. And we already know that angle INB equals to angle IDB. So it equals to 180 degree minus angle IDB, which equals to angle ADC, right? It equals to angle ADC. ANI equals to angle ADC. And what is angle ADC? It equals to 180 degree minus angle ACB minus angle CAD, right? That is 180 degree minus angle ACB. So we got angle ABC plus angle CAB minus angle CAD, right? Angle CAD is half of angle CAB. So it equals to angle ABC plus half of angle BAC. So we know that angle ABK equals to angle ANI. right? Angle ABK equals to angle ANI. Then we know that because N is the midpoint of AB, right? And we know that this angle equals to this one, so we know that IN is in parallel to BK, right? Because N is the midpoint of AB, that means I is the midpoint. I is midpoint of AK, right? And we already know that ACKB are cyclic. That means OK equals to OA. And I is a midpoint of AK. That means OI is perpendicular to AK, which is AI. Right. So for this problem, it's not a very simple problem. I would say it's at least it can be used for a national competition problem. It's not very straightforward. You can you have to understand why this is important, right? If CAB form an arithmetic sequence, why it's important and what we can get from it. And based on that, you can, the next milestone of this problem is that you find out ACKB are cyclic, right? Based on the derivation that they have the same radius of the circumcircle, and that make AKB and ACK, makes the circumcenter have to be on the AK. The circumcenter has to be on the perpendicular bisector of edge AK, right? And it cannot be for the triangle AKB and the triangle ACK. The circumcenter cannot be separate on one side of AK and on another side of AK, because that case only happens under this form, right? Not under this form, which means we find the circumcenter that has to be circumcenter of the triangle AKB is the circumcenter of triangle ACK, which means ACKB are cyclic. This is the most critical part. And once you get these are cyclic, then it's very straightforward to get that IN is in parallel with BK, and therefore you can easily derive that OI is perpendicular to AK, right? You got that I is a midpoint of AK. Okay, this is a very, very interesting figure. I would encourage the audience to explore this figure by yourself, see if you can get more conclusion from this figure. Okay, I hope you like this video. See you in next one. Thank you.